we live and kicking? Oh yeah. Okay guys, welcome. We're probably gonna just give a couple of minutes for people to come. So guys, what we're going to be doing today is basically looking at differentiation paper from 2021, and we're going to kind of go through question 3. So we'll actually you know, the usual, just record at the same time, and then we'll try and answer some questions along the way as well. So next week we'll be starting on the integration paper, guys. So if you are haven't had a chance to look at that paper yet, we'll probably spend some time, probably the next 3 weeks after that. I think that should be enough to cover integration, and then we'll go from there. Hi Japner, where are you coming from today? I'll tell you what, I'll actually do question 1 in about, while we just wait for a few people, 7:52 p.m. So we'll do it at 7:52 p.m. the answer for question 3A. Hey Infinitum, welcome back. Just getting my answer schedule right. 5/78 2021. You know, it's not a good thing to like kind of hurt your this finger here, your writing finger. Jammed it in the door just 2 minutes before, so it's a bit sore at the moment. I can't even, struggling to scroll down the mouse. Frustrating. Hey, welcome King Zag. Yeah, I kind of had to start a bit early today because I woke up at 4:30 this morning, and I haven't actually. Yeah, actually it wasn't 4:30. I think it was 3:30 maybe. I don't know. Can't remember. It's been a long day. So yeah, so I thought I'll just do it a bit early so I can actually get some shut-eye. Yeah. Welcome back, Leo. Hi, Menacing Owen. Who's Menacing Owen? I'm wondering, is this the same Owen in my class or a different Owen? Always like messing around with my year 9s, because every time I do a live stream, I actually go up to my year 9s and I put, hey guys, guess what, I'm doing I'm doing a stream at the moment, and then they come and have a look at it and they start panicking. Well, not panicking, it's just because they've not seen it. There you go, we're back. Let's see how many of them actually show up. Cot X. Oh, it is class Owen. Thanks, Owen. I should have recognized Owen because I was looking at your icon. Alright guys, so what we're going to be doing is we'll actually get through this. I actually forgot what the differentiation of Cot X is, so I need to kind of open up the calculus formula sheet so that I can actually remember it. Give me a second. Calculus formula sheet. You know, it's funny, 2016 and they still haven't changed the formula sheet. Okay, so here we go. Where is it? No, that's not what we're looking at. So it's actually disappeared. Okay, so we're gonna have to add another source. Where am I looking at? Level 3 calculus. There we go. Alright, so we're actually looking at cot x at the moment, and differentiation of cot x is minus cosec squared. So let's actually do this, guys. So we've actually got quotient rule here that we've got to kind of work around with. So I'm actually going to call the top line cot x. So that's going to be u is equal to cot x, and v is, actually hang on, let me just try and start that again because I forgot that I need to actually record this. Alright, so there we go. So question 3a, what we got is we're going to put down u is equal to cot x, and then we're going to put down v is equal to x squared plus 1. So u dash, which is the differentiation of cot x, as I mentioned before, when we actually do differentiation of cot x, we're going to get minus cosec squared x. So that's what we're getting when we differentiate cot x. Now we don't need to actually worry about whatever's inside the bracket, or like whatever the differentiation of x is, because it's just 1. And of course v dash is going to be differentiation of x squared plus 1, which equals to 2x. So with that in mind, we can actually write y dash as u dash v minus u v dash divided by v squared. Now it does say to you guys that this question you don't actually need to simplify your answer. So all you're really using is the quotient rule, and then you're pretty much finished with it. So u dash is going to be negative cosec squared x multiplied by x squared plus 1 minus u, which happens to be cot x, and multiplied by v dash, which happens to be 2x, and all of that is divided by v squared, which is x squared plus 1 squared. So nothing really surprising about that question. That's going to be worth and achieved, and that is basically all you have to do. So remember, with differentiation, I always say this, you guys don't need to differentiate your simplify your answer, particularly at the end, and especially in this case when they actually tell you you don't need to simplify. So don't waste your time, just leave it in brackets, you're good to go, and we get on to the next question. Alright, so for the next question, I'm going to give you guys maybe about a couple of minutes. So we'll actually go through the answers at 7:56. Did anybody else have any questions with number 1 apart from Owen? Which I know, Owen, you're going to ask me this question in 5 years time, so you're a bit too early for that. Here comes another one of mine. How are you going, Lally? So remember, guys, just a bit of a hint for you. Root x have x to the power of half. So that's a bit of a hint for you guys as you try and differentiate this. And if there are any level 2s that's joined us today, remember when we talked about stationary point is when the gradient is equal to 0. So keep that in mind as well. And again, these are achieved questions, right? So I'm not going to be, we're not going to spend way too much time on them. So kind of we'll just fly through them, all right? Yeah, I think you'll be attending a different one, Owen. Alright guys, I'm gonna start doing question 3b here. So I guess the first thing we really want to be doing is getting rid of that root x. So we're gonna rewrite this function here as 4x to the power of half minus x plus 2. So now you don't even need to write it as y, you could actually write it as f of x. And the reason why I like writing f of x is because I can actually put f dash of x is equal to 0 and solve. So I'm going to differentiate this to get f dash of x. So when I differentiate 4x to the power of half, I'm going to get 4 times half x to the power of half minus 1, which equals to negative half. Negative x differentiates to negative 1. So what I'm left over with is f dash of x is actually equal to 2, and x to the power of negative half is just x to the power of positive half in the denominator. And we can also state that because it's x to the power of half, we can rewrite this as 2 to the power of 2 over square root of x minus 1. Now with that in mind, remember we're actually looking for the stationary point. It has a stationary point at q, and we also need to find the coordinates of q. So we need to find out when is the gradient 0, and then once we get the x value, we also need to find the y value. And here comes the third musketeer. What's up, Drew? Alright, so we're going to put f dash of x is equal to 0. And so we're going to have 0 is equal to 2 root x minus 1. And at this point, we've got to try and rearrange this, guys. So rearranging it, what we're going to have is positive 1, because when I have negative 1, bring it over to the left hand side, it is going to be positive 1, and this is equal to 2 root x. What I can do right now is cross multiply, and I've got, when I cross multiply 1 and square root of x, I'm going to get square root of x. Probably should do it this way, just so people don't get confused. So I've got 1 multiplied by square root of x is equal to 2. So I'm going to get square root of x is equal to 2. Therefore, x is equal to 2 squared. Because if I want to get rid of the square root, I've got to square it, which means I'm going to get 2 squared here. And so what I'm getting is x equals to 4. Once I have x equals to 4, I still need to find the coordinates of the point. So I need to go back and figure out what f of 4 is. So f of 4 is going to be 4 times root 4 minus 4 plus 2. And I've got 4 times 2 minus 4 plus 2, which actually gives me 6. Therefore, I can say that q is equal to 4, 6. Now, a slightly longer problem for achieved, because I mean, like, if you think about it, you're differentiating it, you're calculating the x value, and then you got to calculate the y value. And unfortunately, for this question, for the amount of time it actually took me to answer this question, it's still only worth an achieved, because you got to get a correct solution with a correct derivative. So yeah, I'm gonna ignore you three, but as a level 2, this makes sense after learning calculus this week. Oh yes, yeah, Zed. So pretty much this question here, I mean, while it's an achieved question at level 3, I think this will be a merit question at level 2. You'll understand, Owen, when you actually get to year 12, man. Don't worry about it. I'll see you in 4 years time when we'll be sitting here. You know, I just realized, like, that means I would actually have known you guys for, like, if you do calculus in year 13, then I would have known you guys for 7 years of my life. Jeez, that's a long time. Level 2 is year 12, Owen. By the way, guys, any questions on this so far? And if there is, derivative is equal to 0, the gradient is 0, horizontal line. Yeah, pretty much, Eula. I think that's what's happening here. If you guys are happy with this question, guys, I can move on to the next question, which will be a merit question. Because again, like, achieved questions, you want to be spending at least, like I always say this, like, look, in a question, you've got 20 minutes to answer 5 questions. If you are aiming for excellence, you should be getting rid of these achieved questions in like 2 to 3 minutes. And if you're not getting rid of them in 2 to 3 minutes, I would almost say skip the question and go straight to the merit question. Because like this question here, I ended up spending, like, how much time have I recorded so far? Let's see, 5 minutes. So that means I've probably talked for about 4 minutes for this question. Which means if I was to do it, it would have taken me, I don't know, 2 to 3 minutes. So yeah. All right, so we're gonna go to the next question here, guys. Question 3C. And I'm gonna leave it up here for you guys for a while. What I'm also gonna do is I'll put a timestamp of when I'm gonna actually go through the answer. I'll give you guys about 3 to 4 minutes on this, but really 3 minutes, it's not too bad. Have a go at this. Oh yeah, absolutely, King Zag. I mean, like, if you look at that previous question, like, yeah, you will expect people to skip a lot of questions because they can just kind of go through it straight away. And then, like, see, I reckon in that previous question you could have actually put it on the in the graphics calculator, but then you could have still kind of got the right answer as well. So if you actually go into graph, and I think it was 4 shift root x minus x plus 2. Great, I can't actually see it. It's got a max. There you go. So when I actually click on when I plot the graph, I can't actually even see the graph because of our very traditional graphics calculator here. But what you can do is you can actually figure out whether there's a maximum or minimum based on just clicking on gsolve. So if you click on minimum, see it says no minimum found. But if you click on maximum, so we solve it, gsolve, and then click on maximum, it actually tells you that the maximum is 4 and 6. So usually with a local max and a local min, that means it's a turning point. So you know the answer is going to be 4, 6 just by putting it in the calculator. All you got to try and do now is just try and prove it that the answer is actually 4 and 6. Yellow Station Wagon, welcome, welcome. So yeah, guys, another couple of minutes for you guys to try and attempt this question, and then we'll actually go through the answer. Hey Charlotte, welcome back. I know we started a bit early. I think you're still in time for the merit and excellence question. Yeah, Charlotte. So what I'm going to be doing is pretty much going to be doing live streams 3 nights a week. I might actually increase it to 4, but closer to the MCAT. And then when we get to the end of the year exam, I'll pretty much be doing what I did last year. Like, I think we did 5. That was a bit crazy, but what the heck? Why not? Just doing some good for some people. So yeah, maybe 5 closer to the exam. So probably after like term 4, week 1, we'll probably start just hammering 5 tutes, and we'll start doing like different topics, and you guys, you know, whatever you guys want to work on, we'll work on it. You know what was interesting? I had a look at the last stream that I did last week. Man, that got hit about 4K views. It was insane, because it was like someone just came on and just hit the views like crazy. And like all my other videos is like around 200, 300 the live streams, but then that particular one, I don't know why, it's like crazy amount of numbers. Now you're all good, Charlotte. I mean, like, look, it's me giving back to the community, so that's what it is. All right, so let's actually go through question C. What I'm going to do, guys, is kind of slightly just what do I do? Yeah, so I'm gonna move away from chat, and just so that I can just focus on the question, and then I'll finish the question, and then I'll kind of like pause the recording, and then I'll kind of ask you guys how you guys going. All right, so with question C, what we've got is we've got to try and figure out when is this graph increasing. Now, interestingly enough, with this graph is that, you know, we've got to differentiate it. We've actually got a quotient rule, and we've got this increasing thing. Now, if you think about it, what really the question is actually asking is that when is the gradient greater than 0? So that's what it means by when is the function increasing. Because if you think about it, if it has a positive gradient, then the function is increasing. If it has a negative gradient, then the function is decreasing. Positive gradient is a number that's bigger than 0. So I need to figure out when is f dash of x bigger than 0. So I'm going to put down, because it's quotient rule, I'm going to put down u is equal to x, and v is equal to x squared plus 4, which means u dash is equal to 1, and v dash is equal to, just realize x squared plus 4, so that's going to be 2x. All right, so with that in mind, I can now say that f dash of x, which is the differentiation of f of x or y, is actually u dash v minus u v dash divided by v squared. So when we have u dash, that's 1, we don't really care about it. We've got v, which happens to be x squared plus 4, minus u, which happens to be x, and v dash, which happens to be 2x. And all of that is now divided by v squared, which is x squared plus 4 squared. Oh, wow, this is actually an excellence question. Didn't even realize that. So in the numerator, what we've got here is x squared plus 4 minus 2x squared over x squared plus 4 squared. Now we've got x squared minus 2x squared, which equals to negative x squared plus 4 over x squared plus 4 squared. And this is what f dash of x is. Now, if you get up to this point, you will get an achieved grade for this. Now the next part is we actually need to figure out when is this gradient function greater than 0. So in other words, we want to know we've got negative x squared plus 4, negative x squared plus 4 over x squared plus 4 squared. When is this greater than 0? Because remember, when f dash of x is greater than 0, function is increasing. So you might actually put that here in the top there as well if you want to, like a little note, so the marker can actually kind of understand why you're putting this greater than 0 thing. So at this point, we're going to cross multiply the denominator. So we're going to get negative x squared plus 4 is greater than 0 multiplied by x squared plus 4 squared. Now unfortunately that, well, not unfortunately, fortunately that is actually just 0. So we've got negative x squared plus 4. When is it greater than 0? Now in level 2 and level 1, what you guys would have done is you guys would have actually figured out when is this parabola greater than like positive or negative and stuff like that. And remember, we draw a little parabola and try and work it out. Well, in this case, we're going to take a little shortcut, and the shortcut is this. What we're going to do is we're going to actually go plot this particular graph. So we're going to put down negative x squared plus 4. Now, as you can see, when you actually put this particular graph here, we've actually got two x coordinates. So we're going to find out what they are, the roots right there, which is negative 2 and positive 2, right? So we're now trying to figure out when is this graph bigger than 0, and we can kind of see it's bigger than 0 in this particular zone, and those are my two critical points. So if I was to just kind of like quickly sketch it out here on the side, so there's my here's my parabola, which is negative x squared plus 4. I've actually figured out what this point right here is, which is negative 2, and this point, which happens to be positive 2. And if I look at it, when is this graph actually positive? That is this yellow colored zone here. And so I can write my answer here as negative. So between negative 2 and positive 2, we've actually got, yep, that's the child. What do we got? We got negative 2, between negative 2 and positive 2 is when this graph is going to be above the x-axis, so therefore it's positive. And that's all we have to do, because that right there, I'm surprised that this question is actually coming up as an E7. It's a T1 question. T1 question basically means that you get E7 points, like 7 points for it, which is pretty insane. But if you get this part all correct, then you're going to get like excellence and worth 7 points. But if you get this part correct, which is the recognizing the negative 2 and positive 2 as the boundary, then you could get a merit for it. So funny little question in terms of yeah, like in terms of like getting excellence. I was just surprised that this question was actually going to be an excellence. I thought it would be a merit question, but it is an excellence. There you go. All right, anyway, I'm coming back to the chat here. What is this about? Chirag, it's about differentiation. Don't they want when it's increasing? Yeah, you're right, Leo. They do want when is this graphing increasing. Now, what I want to do is I'm going to try and see if I can draw this on Desmos just to show you guys the difference between the graph and the gradient function, all right? So our graph that we have here is x over x squared plus 4. Oh wow, it's actually a really awkward looking graph. Might actually have to do this slightly different. 1 and -1. Who was that asked the question? Yes, Cherry, there is a way to figure out the answers without the calculator. Just give me a second, I'll go through this and then I'll actually show you, all right? So if you guys have a look at it, where's our gradient? -x squared plus 4, -x squared plus 4. All right, where are we at? Desktop, full cam, desktop cam. So here we actually have our original graph, all right? And if you look at our original graph, you can kind of see like it's not really touching 0, but it's kind of like decreasing all the way down here, and then it's increasing for a very short period before continuing to decrease. And so if I go closer and have a look at this, it's around this -2 and +2 where the gradient is kind of starting to decrease again, and it's decreasing here, but in here it's actually increasing. Now when we actually did the -x squared plus 4 as a graph, we're actually getting that parabola there, and you can kind of see like basically what it says is that at these 2 points the gradient is actually equal to 0. Now let's have a look at the original graph. What it's saying is at -2 the gradient is actually 0, and also at +2 the gradient is 0, because anything after +2 the gradient is going to be negative. So that's kind of what's happening here. Questions wise, Leo, that's easy. King, that's nice, excellent question. Yeah, for 7 points it's a pretty neat question. Now Cherry, you want to know how to do this without a graphics calculator. So if you don't have a graphics calculator, what you could do is this step right here. I might actually just record this. Right, one of the questions that actually popped up was like, how do you do this without a graphics calculator if I don't have this -x squared plus 4? Well, -x squared plus 4 greater than 0, what we can do is you can take out the negative as a common factor, and you're going to get x squared minus 4 is greater than 0. And because we've got this -1 in front of the bracket, what I can also do is I can get rid of the -1 by taking it to the right hand side. And remember, in algebra, if you divide by a negative number, your symbol, your inequality symbol must change. And because I'm actually doing 0 divided by -1, the symbol is going to change, and what I'm left with is x squared minus 4 is less than 0. Now at this point I can factorize this because I know that x plus 2, x minus 2 is less than 0. And if you think about this particular graph, x squared graph looks like this. All right, and what we also have is our 2 points, which is -2 and -4. And how do we get that? Because we've got x plus 2 equals to 0, x minus 2 equals to 0. So we can say x is -2 or x is +2. So because of that, that's -2 and +2. Now watch what happens in this situation. Who was it that asked? Cherry. This one you're actually looking for less than 0. And because it's less than 0, it's actually below the x-axis, but the zone still stays the same. The zone is going to be between -2 and x and +2. And what you guys will notice is both of these answers are correct. The only difference is if you don't, I mean, at this level, I don't think they're testing you for your knowledge of quadratic equation, but rather the understanding of it. So if there are parts that you can actually put in the graphics calculator and get the answer out, go for it. All right, there's nothing wrong with that. Cherry, hopefully that kind of answered your question there. All good. Leo, oh wait, I thought you plotted. Oh no, I never plot the actual graph, Leo, because yeah, we really want to plot the gradient function. So Charlotte, I think this particular question, I knew that it was a quotient rule, because with product rule what you have is like, think about it like this. Product rule is when two functions are getting multiplied. Quotient rule is like when one function is getting divided by another function. That's just a quick kind of way to recognize that. But again, the more practice you do with these types of questions, the more you kind of get comfortable with using various rules. Oh, thank you, Eula. You kind of picked that up. All right, guys. If there's no more questions for question C, we can actually go to question D. Let me know. Okay, I guess we'll kind of go to question D. Now guys, I am going to give you guys a bit of time on this because it is a really nice question, and I'm going to give you guys an honest attempt, let you guys have an honest attempt at it. Now if you are unsure and you're like, man, I've got no idea where to start from, I would almost say see if you can differentiate it, because if you can differentiate it, you are going to get an achieved. Alright, if you don't know what to do in a differentiation paper, just differentiate the question, and very likely that you're going to get an achieved for it. It's actually quite a nice question, to be honest. So I'm going to give you guys till about 8:24 to try and figure it out. So 4 minutes. Where are we at? Quiet today. I think everybody's tired. What are we up to? Week 6 already. Jeez. Are we up to week 6 or week 5? No, we're week 5. We're halfway through the term. Oh man. Where is the time going? I have to say the last question in this particular exam paper is a bit of a long bit of working on it, but it's still possible. Alright guys, I'm going to give you guys another couple of minutes, and then we'll kind of go through the answers fairly slowly so that we kind of get the hang of this. Alright, all the clues are given to you guys in this question. It's just figuring out that first part. Charlotte, I'm assuming you figured out what rule to use in this one. What did you get for K, King? T2. So what happens if you get a T1 for this? I'm still kind of a little bit confused about the T1, T2 kind of excellence questions, eh? Because what happens if you don't get a T1 but you get a T2? Does that actually mean you get 7 points? Yeah. Very interesting, this new thing that they've brought in. Yeah, on the money, mate. On the money. Good job. Alright guys, I'm going to start going through this question now. So what we've got here is we've actually got a function. We've been given a whole bunch of information about it. I always like to kind of write things down so I can kind of get a gauge of what it is that's happening, right? So the first thing I'm going to write down is that we've got f of x. F of x is 4x plus k over 4x minus k. The next thing is that we've actually got the line P. It lies on the curve and has an x coordinate of 3. So P has an x coordinate of 3. We don't really care about the y coordinate right now, whatever that is. Well, we'll call it f of 3 for now. Then it also says that the gradient of the tangent to the curve at P is negative 8 over 27. So that means f dash of 3, because the gradient at 3 is equal to negative 8 over 27. So basically these are all the information that we've actually got, that we've received before we even start the question. And looking at this question, we can kind of see that we've got a function that's actually getting divided by another function. And because of that, I'm going to use the quotient rule. I'm going to call u as 4x plus k and v as 4x minus k. So u dash is equal to 4, v dash is equal to 4, and that's what I am looking at. Now the next part is of course calculating f dash of x. So f dash of x I've got is u dash v minus u v dash divided by v squared. So u dash is 4, v is 4x minus k, minus u, which happens to be 4x plus k, and v dash, which happens to be 4. All of that is divided by v squared, which is 4x minus k squared. Okay, so obviously I kind of need to simplify this a little bit. So I'm going to expand the brackets here. So I've got first these two brackets to expand, then I've got these two brackets to expand along with that minus. So what I'm going to end up with is 16x minus 4k minus 16x minus 16k. I'm not happy with that. Like, I feel like I've made a, no, minus 4k, sorry, there we go. Thought I made a mistake with that. And all of that is 4x minus k squared. Now, let's say you got up to this line right here, you're going to be looking at an achieved. So that's what I'm talking about. You know, even if you differentiate this question up to that part there, even without simplification, you can actually get an achieved. Now, this gradient function, of course, can be simplified further, because we've got 16x take away 16x, and so what we've got here is negative 8k over 4x minus k squared. Okay, with that in mind, now what we're going to do is we're actually going to put down f dash of 3. F dash of 3 is equal to negative 8 over 27, and because this is the gradient function, what I can then say is negative 8 over 27 equals the gradient function, which happens to be negative 8k over 4x minus k squared. But of course, remember that x is actually equal to 3, so I can actually put that as 3 and figure out how I'm going to actually figure out the value of k. So I've got negative 8 over 27 equals negative 8k over 4 times 3 minus k squared. Now, of course, I can look at this numerator. Both the numerators have minus 8, which means I can get rid of them. But before I do that, what can I do? Yeah, I might actually just switch one of the negative 8 so I can kind of cancel it. So I'm going to get negative 8 over 27 multiplied by negative 8, which is this one here, equals k over 4 times 3 is 12, so 12 minus k squared. But of course, I've got negative 8 and negative 8 that cancel out, and what I'm left over with is 1 over 27 equals k over 12 minus k squared. So with this in mind, I just have to rearrange this quadratic and solve it, and I should be good to go. So taking across and cross multiplying, so I've got 1 times 12 minus k squared equals 27 times k, which is 27k. I can forget about the 1. I need to expand the bracket here. I've got 12 minus k times 12 minus k equals 27k. So I've got 144 minus 24k plus k squared equals 27k. Now bringing the 27k to the left hand side, plus k squared equals to 0. So I've got k squared minus 51k plus 144 equals to 0. Now at this point, guys, again, if you don't have a graphics calculator, you're gonna have to kind of, it's gonna be a bit difficult, all right? But otherwise you can always use the quadratic formula. But in our case, because we have the graphics calculator, what we're going to go is we're gonna go straight into equation, polynomial, and we've got number of degree 2. So we've got 1 minus 51 and 144. And when we press solve, we actually get two values. So k is equal to 3 or k is equal to 48. And if we get that two values there, we end up getting a merit grade for this. Yeah, a bit of a long question for a merit actually, because of that rearranging and then doing the quadratic. No worries, infinitum. See you later, mate. Alright guys, so any questions on this particular question? Any issues, challenges? Let me know. And then if we're good with this, then we can actually go to the last question, which is an excellence question. By the way, when this is finished, I'll actually put all these 3 questions together, stitch it up, and then I'll upload it later. What did you put in the calculator? Oh, I actually put the quadratic equation in the calculator. Yeah. So the polynomial part, I actually put it in the graphics calculator under equation. So you go into equation, and then you click on polynomial, which is F2. Degree 2, because we've got k squared. And I've just put in 1, negative 51, and 144. So that's the A, B, C of a quadratic equation. And of course, the reason I did that is because then it's going to give me the two values for k. Okay, no worries. Any other questions, guys? Otherwise, we can go to our last question for the day, which is an excellence question. It's a T2 question. 16 hours, man. All right, let's go to the last question, guys. It's a bit of a read here. So what I might do for this question is I might just give you guys like a few minutes, because I think I'm actually gonna need a coffee because I'm like falling asleep here. So we'll say I'll be back at how much time do you guys need? I think you guys would need a good chunk, so we'll actually make it 8:38. So guys, I'm gonna give you guys about 4 to 5 minutes for this question. Have a go. If you have any other questions, just pop it on the side chat there, and then yeah, we'll try and get to it. Hey Beckham, welcome back, man. Welcome back. I think I was just saying I need a coffee because I'm like been up since very early this morning and yeah, starting to crash slowly. Coffee time. Be right back, guys. Yeah, even I haven't actually read it properly yet, so I started reading it and I was like, okay, let's see. I need coffee first, but I'll just read it and then I'll go get my coffee. I think you guys actually need a bit more time than 8:38, so I might actually boost it to 40, guys, because and if you're not sure what to do in this case, whenever you get questions like this, like especially like optimization questions or anything like this, they're giving you a big clue here by actually putting that equation there, you know, because you want to differentiate I. The problem is you cannot differentiate I because you've actually got two variables that's there. One is theta and one is s. So you've actually got to figure out a way to get rid of I'm trying to think. It's like, yeah, you've got to get rid of the theta, right? Because it's just awkward. Then why? Adjustable. P point P directionally proportional is proportional to the square of distance. Lots of substitution happening in here. Sorry, did I say 848? I was supposed to say 840. Yeah, Raphael. It's I got it in Colombia, man, 10 years ago. Actually, no, I didn't get it. Did I? Nah, my sister got it for me when she was in Colombia. By the way, that Colombia t-shirt, I mean the spelling of Colombia, it's L-O, man. A lot of people get mixed with that because that's the state in one of the states in US, but this is the country that we're talking about. Alright guys, let me know if you want me to just go through it. I forgot to get my coffee because I was sitting here looking at the answers, trying to figure out how to explain it. But otherwise I'll just start at 8:41 and just slowly start working my way through that answer. Is that a yes please, you need more time, Charlotte, or do you want me to start going through the answer? By the way guys, this is a proof question, so you know, if you have started working on this question already and you don't want to, you kind of need a bit more time, I'd probably say to you guys, just mute me and just kind of work away at on your question just to see whether you can actually get the proof of h is equal to r over 2, square root of 2. Okay. Nah, this Cherry, this is an excellent question. I would say this is probably going to take about good 6 to 8 minutes, I would say, to try and do this question in an exam. Now, it's all good, Zed. That's what we're going to try and go through, all right? So, I think what you guys need to kind of understand is that when you say you don't know how to start the question, right? Like, I mean, if you think about it, the first kind of rule of a differentiation paper is that you've got to differentiate things, okay? Now, if we were to follow that rule of actually, yeah, I know it's a differentiation paper, I've got to differentiate it. The problem here, though, is you can't actually differentiate I. So I actually should record this, hang on. So looking at this question, you know, like some of the, I think, what was it? One of the comments was that, like, you know, I don't know how to start this question. Well, here's the thing. As I said before, like in a differentiation paper, you want to try and differentiate everything, right? That should get you achieved. But the issue here, though, is what we are trying to differentiate. We're actually trying to differentiate I. And there's a few things that we need to understand, all right? There's actually, first off, when you differentiate like a normal graph, you're going to have something like this: y equals to x cubed plus 3x squared and whatnot. Now, in this case, you've only got one variable, because remember, when you actually do differentiation of this particular function, you would write this as dy dx. The issue is, with this particular equation, we've actually got I equals to k cos theta divided by s squared. And going back to one of the comments there, I have no clue of how to do this. Well, how would you differentiate this? You can't. The reason you can't differentiate this is because you've actually got three variables here. Variables are things that are changing. Constants are things that are not changing. So let's actually see if there are any constants in this equation. Our first clue is this one right here. K is a constant. Okay. Because K is a constant, now I either need to I either am going to get a theta as my d theta, or I'm going to get ds. But the problem again is that's still going to complicate things, right? Because let's have a look at like theta. Like it's just, you're going to end up with a really ugly looking equation. But the other thing that's worth remembering is we've actually got cos theta. Now if you think about cos theta is ka, as in Sokotoa, it's adjacent and hypotenuse. So we can actually say cos theta is actually equal to, so we can say cos theta is equal to adjacent divided by hypotenuse. Adjacent is there, I'm just going to write that in a different color. That's adjacent and that's hypotenuse. So we can actually say cos theta is equal to adjacent, which happens to be h, over s. All right, so this is our next part. And guess what we've just done? We've actually just eliminated k, which was a constant, but we've also got rid of cos theta because we can actually replace it with h over s over s squared. So what we then can do is we can rewrite this as k h over s cubed. Sorry, I forgot that I actually had this up here. But that still gives us the problem that we've actually got two variables. We've actually got h as a variable, and we've got s cubed here, which is still a variable. We still need to figure out a way to get rid of this s. And I guess this is where your Pythagoras comes into play, because we can actually write this as s squared equals h squared plus r squared. How do we know that? Because that's a Pythagoras triangle, like it's a Pythagoras theorem, right? You've got a right angled triangle there, which means you can actually say s squared equals h squared plus r squared. And because of that, we can actually say that s is equal to h squared plus r squared to the power of half. And so what we're going to do next is that we're actually going to take this s, which is h squared plus r squared to the power of half, and we're going to replace it there. All right, so we're going to do that. So we're going to go I is equal to kh over h squared plus r squared to the power of half, and the whole thing is raised to the power of 3. But guess what? We've got two h's, but we've also got an r now, and that's annoying because we know that k was a constant. Is r a constant? Well, let's go have a look at the question again. And if you look at the very first line, it actually tells you that a lamp is suspended above the center of a round table of radius r. Now think about it. If you have a round table with radius r, is that a constant or is that a variable? Is your table changing size? It's not changing size, it's the same table. Because it's the same table, we can then say r has to be a constant because the radius of the table is not changing. So that means r is going to be a constant, which also means we now can actually differentiate this function as di over dh, because we've got two constants and we've actually got h as our variable here, which is the height. With that in mind, Charlotte, I think it's your favorite quotient rule that's actually come back here again, but yeah, so we've got quotient rule here, and so that's what we're going to do. I'm gonna kind of like shift over to the side here, and I'm gonna write down u is equal to kh, and then what I'm going to do is I'm going to write down v is equal to h squared plus r squared. Now half times 3 can be written as 3 over 2, so leave that out there. U dash is equal to k because I'm differentiating with respect to h. V dash is equal to 3 over 2 multiplied by h squared r squared to the power of half, because 3 over 2, which is 1.5, minus 1 is equal to 0.5. And I've got to multiply by the differentiation of this with respect to h. And because of that, I am going to multiply it with 2h. So with that in mind, I've actually got my gradient function. I'm just going to call it di dh is u dash v minus uv dash divided by v squared. So u dash is equal to k, v is equal to h squared plus r squared to the power of 3 over 2 minus u, which happens to be kh, minus v dash. I'm going to cancel these two 2's. I'm going to cancel this 2 and this 2, and what I'm left over with is kh times 3h times h squared plus r squared to the power of half. And of course all of that is divided by v squared, which is h squared bracket r squared to the power of 3 over 2, and that's all raised to the power of 2. Super ugly equation, but it's going to work. All right, so what do we have here? We now know we are trying to prove that when is the maximum, right? Because before we even put down maximum happens when the gradient is equal to 0, we want to actually tidy up this equation as much as we can, just so that it makes it a little bit easier for us. Otherwise it can just be a pain trying to deal with this later on. So I've got k and I've got h squared plus r squared to the power of 3 over 2 minus 3kh squared, h squared plus r squared to the power of half. All of that is divided by, now 3 over 2 times 2, 1.5 times 2 is just 3. So we can write this as h squared plus r squared to the power of 3. Okay, where's my 3 at? There we go. So at this point we can kind of say, I'm going to kind of skip a couple of steps here, but I'm going to do it slightly different from the answer schedule. So because we know the maximum happens when di over dh is equal to 0, so we can put down 0 is equal to k h squared plus r squared to the power of 3 over 2 minus 3k h squared bracket h squared plus r squared to the power of half. And all of that is still divided by h squared. I am not having fun with my pen today. I wonder if the batteries actually run out for this. It's alright, let's just keep going. It's not working. So far so good. Now I'm going to cross multiply the denominator with 0, which means it will become 0, and I've got 0 is equal to k. So I might just put this out here so that people don't get confused. So we've got h squared plus r squared to the power of 3. That's getting multiplied here with 0, so that's going to become 0. And in here we've got h squared plus r squared to the power of 1.5. I'm going to write it as 1.5, and I'm going to show you guys why I do that. Minus 3 kh squared h squared plus r squared to the power of 0.5. Something is up with my tablet, guys. Sorry, just give me a second. I'm just going to try and see if this works. There we go. That's a lot better. So that's where I'm at so far. So my left hand side is now equal to 0, and on the right hand side I can see that k is a common factor because both of them have k. I can also see that h squared plus r squared to the power of 1 is a factor. So I'm going to take that out. So I'm going to take out k and h squared plus r squared to the power of 1. When I do that, inside the bracket I've got h squared plus r squared to the power of 0.5 minus 3h squared. Let me just check if that's correct so far. Trying to see if I picked up everything right here so far, guys. Did I factorize that right? 3 over 2 minus 3k That's all looking good. Cross multiply that. That's gone away. Was it actually worth doing it this way is what I'm trying to figure out. I just realized what I made a mistake with. I did make a mistake. Yeah, just having a look at it, I just realized I made a mistake. 1 is not a common factor, it's actually 0.5. So I need to redo this one again. Hang on. That can't be 1 as a common factor because I've only got 0.5 as a common factor. So I need to take 0.5 out as a common factor, which means I'll actually have h squared plus r squared to the power of 1 minus 3h squared. Is that better? Yeah, that's a lot better. Sorry guys, I kind of just got distracted with that 1.5 and 0.5 there. So far so good. What else could we do from this point onwards? We can actually kind of go 0 is equal to k, come on, h squared plus r squared, 0.5 times r squared minus 2h squared. Okay, so we've actually got two little things that's happening here. We've actually got kind of like two brackets that's equal to 0. So we could kind of just do that straight away. I'm just having a look at it. Can we do this? Yeah, we could actually get rid of the h squared and r squared as well to the other side. We can also get rid of the k to the other side, which means we're only going to get r squared minus 2h squared equals to 0. But what would happen if I put it as that? If I put h squared plus r squared equals to 0, then I'm going to get h squared equals to r squared. That doesn't work, right? So at this point, guys, what I'm going to do is I am going to take this entire looking thing here, this whole thing to the other side, and I'm going to divide it by 0. So it's going to be not divided by 0, 0 divided by that. So I'm going to get 0 that is actually divided by k h squared plus r squared to the power of 0.5 is equal to r squared minus 2h squared. Come on, man. I think my pen is just killing me at the moment. R squared minus 2h squared. There we go. And because 0 divided by that number will be 0, we're going to get 0 is equal to r squared minus 2h squared. And if we were to rearrange that, we're going to get 2h squared is equal to r squared. And then r is equal to square root. No, we're trying to prove h, right? Oops, sorry. So h squared is equal to r squared over 2. And then we're going to get h is equal to square root of r squared over 2. And so finally, we get our answer of h is equal to r over square root of 2. Lots and lots of working out there. Now, I think that's what the question actually asked right about here, where it said prove that the maximum happens when h is equal to r over 2. Very frustrating question because like there's a lot of algebra actually involved in this, but still it's not too bad because, you know, it just, I wouldn't say okay, it's not okay, it is bad, I'm not gonna lie. It is a bit of a annoying question for like compared to the other excellence question that we did just like 10 minutes ago, which took literally 5 minutes to explain. What are we going to get for grades for this question? Correct expression for dIdh gets you a merit. So that is basically here. You're going to be looking at a merit, and then your final answer with the correct proof is what you're going to be getting for an excellence. That's a long question for an excellence, but hey, when you get those other gimmies in question 2 and question 1, I guess it's not so bad having one tough question in there. Hey mate, from year 12 here, just curious if you're going to do level 2 calculus and algebra 2021 exams. Liam, I've already finished the level 2 algebra and level 2 calculus exams, mate, so it is already up online. Look up my channel and you will find it. All right. Yeah, Charlotte, and I think that's all right, Charlotte, because if it actually makes sense to you, that means you are understanding, and the more you do these types of questions, the more exposed you are to these types of questions. So when you do get a question like this in the exam, you're like, yeah, okay, it's a long one, but it's a long question, but because you've actually kind of seen it, because you kind of seen it, you kind of will start to realize that, oh, actually I can actually just need to kind of do these little tricks here and there. Beckham, you did it last year, right? I can't remember. Or did you do it this year? Or no, or like, did you do it as a practice this year? Ah, so you did, yeah. Yeah, that was a bit of an annoying question, this one. Like, just looking at the length of how much work I had to do to, like, I think, you know, the frustrating thing about this particular question is like getting the equation, because, you know, you get, like, look at how many lines I had to do just to get to that equation. I started with k cos theta over s squared, and then I had to get rid of s first. Then I got rid of s cubed, you know, and then I've got to realize that r is a constant and k is a constant and so on. Yeah, I hear you, King Zag. I mean, like, I think, you know, that's why I'm not a big fan of this T2, T1 questions. But then again, T1 questions, if you get 3 T1 questions, you can get 21 points, which is like, oh, it's not bad, because that's going to get you an excellent straight away. But these, like, if I look at this exam paper and I know that see, and this is the stink part about it, right? Because you actually don't know whether it's worth a T, that question C was actually worth a T or not, because that's, in my opinion, I wouldn't have put that as a T1, that question C that we did, the increasing question. I thought it was a merit question, but then they decided to call it excellence, which kind of was like, well, you know, I feel for the guys that don't know what these exams are like, and they end up doing this particular question they'll do for such a long time, because they might have actually missed the merit question and go, oh, usually once, like question 3C would be a merit, but then it ends up being an excellence, which kind of sucks. But yeah, anyway guys, that is us for today. Good question. What should I do for that? Is that what do people normally do? Do they sing and dance, or what is it that they do? Be interesting to know. Yeah, 25k. What, we've got another 500 to go, is it? Okay, we've got another 450 56 to go. And what do you guys want? Do you guys want a t-shirt or something? A signed t-shirt? Shall we do that? Or a visit to their school? Oh, that'll be interesting. A signed NCEA paper. Oh, that is a crack up, Sherry. That's a crack up. A signed NCEA paper. Now I reckon we can do a special edition T-shirt, right? Like what do people do? Do they actually like do they do like a live stream as their subscribers go up? Because I don't know, I've never done this, right? It's pretty phenomenal to try. For me it's like 25k. Geez, that's pretty cool. A cap or something. Now I've already got a cap, man. I can give my cap away. Hang on, let me, yeah, I could do a cap. Now we got to do something big, right? We got to do something big. What do we do? But a cap or a t-shirt? You guys pick. Not Beckhamster, you're back, man. Infinity +1 t-shirt. You know, most likely I'll actually make it myself, right? Like, cause it's just like so easy to do that. Both have 2 winners. T-shirts are a lot more easier. T-shirts are a lot more easier. I mean, like, I can just go grab like a few Kmart t-shirts and just kind of like get it done. But maybe we should make it into a bit of an event. Okay. Maybe I'll put it up on the community and Instagram just to say, what should I do when we hit 25K? What, like, how do giveaways work? Like, do I just kind of go, whoever's in the stream, or like whoever's in the stream will just pick a random person? Is that how it works? I need to look it up. I already have now Beckhamster. I released like a whole bunch of masks, so I think I had like 2 people, no, 1 person, no, 2 people that, 3 people that wanted to buy it. 1 of them that actually bought it. It's like I've got like a whole bunch of Infinity +1 masks at home just sitting around. So yeah, maybe I'll throw that in as well. That'd be good fun. Nah, you don't need this, Sherry. Like, no, okay. Honest question. Like, I think Beckhamster. I know that. I think you're in Auckland. Like, how many of you guys are from Auckland? Because I'll tell you what. I think what I will do is I will actually hand deliver the t-shirt. Now, how cool, like, if it's in Auckland, I will hand deliver the t-shirt. If it's like elsewhere, I would have to post it, man. There's no way I'm flying down to Wellington or Christchurch to give a t-shirt. Vader, if you win, you can just come across the road to junior college and pick it up, all right? Because I'm not coming to senior. Drive to Hamilton, I will do. I will drive to Hamilton, because the thing is, it's like, look, Charlotte, I've got people. Yeah, I was gonna say I'll just send it to her. She can give it to you guys. She's pretty cool. Hamilton, I can kind of drive down, because usually I drive down in the holidays down to Wellington anyway. At least I come down as far as Wellington, but Christchurch, man, that's a bit of a slog there. Why? Because it's like, I haven't even been there in like 3 years, man. I left 2.5 years ago. It's now not primary, Beckham. I went to intermediate. Like, earlier in the stream, I had like some of my year 9 students join me, and they're like, "Oh, what's cot X? What is f dash of X? What is that 0 thing that you do?" The switch. I made the switch because partially I kind of wanted to teach calculus my own way. Like, I didn't want to do it with like marking exams. I didn't want to do internal assessments. I was just lazy. And I just wanted to kind of like just teach when I wanted to teach without having to kind of like worry about things. Well, here's an Easter egg for you, Vader 2005. There is a couple of Infinity +1. Before I left the school, No, I probably shouldn't say this because considering I'm actually going to the school tomorrow, and if someone actually goes in and tells what I did, I'll probably be in trouble. But there are certain signatures I left on the school of Infinity Plus One was here on certain places. I think Mrs. Moss is going to kill me for that one. So, but yeah, there are a couple of Easter eggs within that school somewhere. Who's your teacher, Veda, for calculus? Yeah, tomorrow. I'll see if I can go and leave a couple of stickers. Should I do that? Should I grab like a whole bunch of Infinity Plus One stickers? I'll make it tomorrow morning and just go put it around OSC. Yeah. Oh yeah. It's a cool little story she told me once I met her. She said, I'm the teacher that replaced you. I think, yeah, when I left, she was one of those teachers that came in. Yeah, I actually wanted to do that around Auckland, but I think Auckland City Council would actually like kind of get me in trouble because I wanted to go around bus stops to put Infinity Plus One QR codes. Hey, are you studying NCEA maths? You should actually go to this site. Anyway, guys, that's me today. I've had a super long day. It's been lovely having a chat with you guys after that end of those horrible excellence question. But yeah, have a good what are we up to? Week 5 right now, right? Good weekend. And what we'll do is next week we will start going through integration. All right, so integration paper, we've got the usual 3 questions. That should take us to week 6, 7, 8. Plenty of time for you guys mock exams. By that time we should be up to mock exams. If for any reason you guys do some mock exams earlier and you kind of get stuck with certain questions, I would say, look, just get a mental picture of it. Don't take a screenshot of it. Get a mental picture of it, and maybe, you know, just throw the question out my way, and we can have a play around with it to try and figure out how to do these questions. Yeah. Mock start at week 8. Okay, so we probably need to do an integration one a bit early then. Oh yeah, because you guys started. Yeah, that's right. Yeah, week 8. I thought you guys would go to week 9, but obviously they. Okay, that change has happened. Is it all? Are all of you guys doing week 8 mocks? If that's the case, would you guys mind doing another like another session, extra session for integration? When is yours, Charlotte? We've got 3 more subscribers. What week? Wait, term 4, week 4. Because obviously week 4 and term 3 is gone ahead already. But wait, you guys already finished your mock exams? All 3 externals, like complex numbers, differentiation, and integration. Yeah, that's pretty insane. That's like, so what do you guys do for the rest of the time? I have to have a word with Dr. D to find out what's the program is, man. Jeez, that's insane. Oh, so you guys are doing externals first and then now you're doing internals. Right. Makes sense. I was wondering about that. I was like, how could you finish so much in so little? Yeah, no, Beckhamster, I kind of needed to do that because like because people were kind of like asking me all the time questions like, oh, when is this video coming, when is your live streams and so on. So I was like, you know what, I'm just gonna change it up By the way, you guys haven't actually answered the question. You guys haven't actually answered to would you mind doing an extra like a Wednesday night to catch up on that integration rather than like a live stream on a Wednesday night so that we can actually do that integration paper before mocks? Would that help? Okay, cool. So what we'll do then next week, instead of doing it on Thursday, we will actually start on, I'll see if I can get permission from management at home. That's right, I need permission from management at home to see whether we can actually kick it off on Monday. And then we'll try and do Monday, Wednesday, Thursday. If we can, we'll try and get rid of it so we can actually finish integration. And some people wanted me to do like, they wanted me to do them like what I did for Mathdemic with complex numbers. They want me to do for differentiation. Do you guys want something like that where I go through the whole topic but like try and kind of explain things in a way where I connect exam questions at the same time as doing the skills as well? Because I know, Charlotte, you kind of were asking me like, you know, when do I use quotient and when do I use product? It's just, I can show you what I do is like I kind of do the questions, like the skills first, and then we pretty much go and do exam questions that represent those skills. So you guys kind of go, oh yeah, this is what the skill and this is what the exam is going to be like. I call it the triple threat rate of change, or triple threat rate of change question. Okay, so what I'll do is keep an eye out on Monday. At least if it's not on Monday, we might be doing it on a Wednesday for sure. I will see if I can try and get permission from management at home to kind of run that tutorial on Monday. So we'll try and finish integration, because then that gives me a peace of mind. I don't have to worry about doing that again. Cool. So guys, that's us today. I will, like I said, keep an eye out. It'll be either Monday or on Wednesday. Oh great, now I've gone to 2560. It's like 6 subscribers since I said I was going to give t-shirts out. Jeez. Yeah, so keep an eye out on Instagram or also on the feed. Like if I do start if I do go live on Monday, I might just go like at about, give you guys 5 minutes, so if you are doing something you can still get stuff sorted out and then actually come to the tutorial. Right, I will leave you guys to it. Have a good one, guys. Have a good weekend. Rest up, enjoy the weekend. Yeah, and I will catch you guys on oh no, you just had to ask that question, Eula. How did I find university maths? I failed, man. Every tutorial, at the end of every tutorial I have to talk about this. It's like, no, I failed university maths. Like first 5 years I failed, and then got my act together and kind of finally got my degree. So, but look, end of the year we'll have like this big 2-hour session of, actually no, we'll probably do that for the 25k one. We'll do like a nice Q&A and we'll do giveaways and whatnot, and I don't know, we'll just do it on a Friday night or something like that. Oh, I actually have a degree in mathematics and stats, Charlotte. So it's a full degree in maths and science and stats, but I just bumped around a lot. Anyway, that's me, team. I will catch you guys later, and have a good one. Stay safe till the next time.